So what I want to cover in this lecture is that I want to tell you the properties of sine, cos, tan graphs. How do they behave, and what are the important things that we need to know when we look at the graph of a sine curve or a cos curve or a tan curve. And we'll also try to understand what is the meaning of y is equal to a cos bx plus c, y is equal to a sine bx plus c, y is equal to a tan bx plus c, where a, b are integers. Don't worry much. We will we will be taking examples. So basically, what I'm trying to say is that you see y is equal to if you see y is equal to sin x, I hope now you have understood that y is equal to sin x is a simple graph which looks like this. Have you understood this part?
Yeah.
Okay. Now what I want to tell you is that let us say that someday you meet a function like this. Y is equal to 5 sine 3x plus 7. Have you understood?
Yeah.
Now, how does the graph of y is equal to 5 sine 3x plus 7 looks like? And it has this graph. Do these two graphs have anything in common? That is what I'll try to cover in this lecture. Have you understood? Have you
Yeah.
understood the scope of this lecture?
Yeah. Yeah.
Okay. So we'll just start from absolute basics. So, this is what we were discussing that, now I'm in a position that I can plot the values. I can make a table like this where sine, cos, tan is written and for various values of 0, 30, 45, 60, 90, 120, 35. So for all these value, I am able to find the values of sine 60. I can find the value of sine 135. I can find the value of sine 240. I can find the value of 315. I can find the value of tan 225. I can find the value of tan 300. I hope this is, I hope this part we will be, we easily would be able to do with the amount of knowledge that we have as on date. This is one thing. Do you agree to this?
Yeah. Yeah.
Because now we have done the trigonometric identities, we have understood all sine, tan, cos, we have understood, in the last lecture, we understood how to find the values of allied angles. We did all that stuff. We basically, to complete this table, the things that we require are, we require some knowledge, we require knowledge of how to find the allied angles. This is what we did in the last lecture.
Yeah.
Then in one of the lectures, we looked at the unit circle also. We looked at the unit circle also. So
Yeah.
using the values of this unit circle, I'll be able to make a table like this. So reaching this table with the knowledge that I have as on date shouldn't be an issue. Do you agree to this or not?
Yeah.
Yeah. So once I have these values, we will just focus on the sine, cos, tan part. We won't focus much on the cosecant, secant, cot part for a simple reason that in physics, we
Hmm.
would be more focused on the curves of sine and cos. These would be very important for us. The math student would be, the math guys would be interested in cosecant, secant, cot, but right now, for the amount of physics that we are doing, a healthy amount of idea about sine and cos curves would would be sufficient for us. Are we okay till here?
Yeah.
Okay. So what we have been discussing in the last one or two lectures is that using these values of sine. So for example, for 0 degree, the value is 0. For 30, it is zero point 0.5. So for 45, it is zero point 0.7. For 150, it is zero point 0.5. So for various values, I can plot the 30, 60, 90, 120, the angles on the x-axis, and I can plot the values of the respective values of sine like this.
Yeah.
I think this is what you were able to do today.
Yeah.
And then you would have seen, not exactly, but you could have seen a sort of trend that this is how it looks like. You would have
Hmm.
agreed that yes, the curve of sine looks something like this. Do you agree to this or not?
Yeah.
Okay. And I told you that we are more interested in the sine. We are not much interested in cosecant for
Hmm.
the physics part. So
Hmm.
similarly, when I look at the values of cos for various angles, I have the values of cos. And for cos also, if you start plotting, then you would have seen some trend like this.
Yeah.
कि भाई कुछ तो ऐसा हो रहा है. You will
Hmm.
get a not exactly, but you would have seen some trend कि हाँ अगर मैं if there is a curve like this, yes it makes sense. हाँ ऐसा एक
Hmm.
curve
Hmm.
नजर तो आता है ना?
Hmm. Yeah.
So similarly, I have values of tan, and I
Hmm.
agree, and I agree to what you were saying. See, if you look closely, for tan, 0, 0.57,
Hmm.
1, 1.73. So basically, if you if this is 30 degree, uh, let me say, yeah, this is 30 degree. Let me say this is 90. This is 90. 30, 60, 90. This is minus 30. This is minus 60. This is minus 90. So here I only have one other value, which is 45 degrees. Now once I
Hmm.
start plotting, so this tan 30 is 0.57,
Hmm.
tan 45 is 1, tan 60 is 1.73. Similarly, if I plot on the negative side, this would be 0.57 minus 0.57. This would be
Hmm.
minus 1. This would be minus 1.73. And of course, at tan 90, it goes to infinity, or we say it is undefined. So here, it takes a stretch of limit. Your imagination. You have to stretch your imagination, but you have to trust that the graph of tan looks something like this. Have you understood?
Okay. Yeah.
So I understand that this requires a stretch of imagination, but then you have to, take it for granted कि भाई ऐसा ही होगा. मेरी बात समझ आई
Hmm.
आप?
Hmm. Yeah.
Otherwise, otherwise, what we can do is another thing that we can do is so this is the line where it goes to infinity. This is how loosely this is how the graph of tan looks like. It looks like a rain shower. That rain is falling.
Hmm. Hmm. Hmm.
So
Yeah.
otherwise, what we can do is there is a, in one of the lectures, I'll show you that software also, Desmos. So we will be using that Desmos application. It is available on Firefox. It is available on Google Chrome. We'll be using that to plot various kind of graphs.
Okay.
Or otherwise, you trust me that yes, the graph of tan looks something like this. And to give you a fair amount of idea, you can plot the values, and you can have a at least a basic level of understanding कि हाँ यार ऐसा ही लगता होगा.
Hmm. Hmm.
Do we agree to till here?
Yeah. Yeah.
So now we come to our book. So in the textbook also the same kind of things are being said, that the graph of sine is, if you see, the value is between 1, this is the maximum
Hmm.
value, and minus 1.
Hmm.
So on both sides, on the right side, on the left side, the angles can go from 0 to infinity. But the value of sine would always remain between 1 and minus 1. Similarly, if you look at cos, on both the right hand side and the left hand side, the values of cos will always be between 1 and minus 1. Do we agree to this?
Yeah.
Okay. The second thing that I wanted to tell you was the same thing that we had learned in all tan, sorry, all sine tan cos, all
Hmm.
sine
Hmm.
tan cos. The same thing would be verified here also. So if you see, this is my first quadrant. Here sine is positive. This is my second quadrant, 90 to 180. Again, my sine values are positive.
Hmm.
I should write this as sine is positive. But when
Hmm.
we come to the third and the fourth quadrant, if you see, the values of sine have turned negative.
Mm-hmm.
Avantika, am I making sense or not?
Yeah, yeah.
Or let me write it like this. I think then it will make more sense to you. So what I'll do is I'll write it like this. This is the first quadrant. This is the
Hmm.
second quadrant. This is the third quadrant. This is the fourth quadrant. If
Yeah,
you see in from 0 to 180, the values of sine are always positive. But
yeah.
in third and fourth quadrant, the
Hmm.
values of sine are negative. Is
Negative.
it making
Yeah,
sense?
yeah.
Similarly, when we look at the cos curve, now again let us divide cos into four quadrants. This is
Hmm.
the first quadrant, 0 to 90. 90 to
Yeah.
180 is the second quadrant. 180 to 270 is the third quadrant, and 270 to 360 is the fourth quadrant.
It's important.
Again, when I look at this, all sine, tan, cos. So first quadrant, cos is positive. Yes, of course it
Yeah,
is positive.
yeah.
90 to 180, cos is negative.
Negative.
Yes, it is negative here, cos is negative.
Yeah,
Third quadrant again, cos is
negative.
negative. And fourth quadrant, cos becomes positive again.
Hmm.
Is it making sense?
Yeah, yeah.
So the graph support whatever trigonometry that we have learned till now. Is it making?
Hmm. Yeah.
Okay. Now let us have a look at the tan curve also. So this is how the tan curve looks like, as if rain
Hmm.
is falling. So
Yeah.
again, if I want to verify my all sine tan cos, see 0 to 90 is my first quadrant,
Hmm.
90 to 180 is my second quadrant, 180 to 270 is my third quadrant, 270 to 360 is my fourth quadrant. So 0 to 90 is positive. Yes, it is positive. Now, if you look at 90 to 180, the values of tan would all be negative. Is it making
Hmm.
sense?
Yeah.
Then, when I cross 180 to 270, the values of tan start taking positive values. And of
Mm-hmm.
course, that is true. I learned this in my after school to college, add sugar to coffee. So, the same thing I have learned previously also. And when I look at my 270 to 360, my fourth quadrant, here if you look, the values of tan, they are taking negative values. Is it making
Hmm.
sense?
Yeah, yeah.
So this is the basic discussion that I wanted to have about the curves of sine, cos and tan. Now for us, I'll just, I'll just tell you so that you are aware. So in class 11th, we'll be meeting these circular functions. The major part of these circular motions would become very important when we are doing simple harmonic motion,
Hmm.
simple harmonic motion, and when we are doing waves. So these are the last chapters of physics, class 11th.
Hmm.
So
Yeah.
whatever we are learning now, the sine and cos curve,
Hmm.
they will be very fundamental to these two chapters. Okay, so now that we have, a good understanding, fair amount of understanding that how a sine and cos curve looks like. Now there
Hmm.
are few, you know, things related to these curves that we'll have to understand. So the first thing that they are saying is that sine and cosine functions are called periodic functions because they repeat themselves again and again. Does
Hmm.
it? The second thing that they are saying is that the period of a periodic function is defined as the length of one repetition. The basic sine and cosine function repeat every 360 degree. We say that they have a period of 360 degree. Is it making sense?
Okay. Yeah, yeah,
So see, all they are saying is that after every 360 degree, sine curve will repeat itself. That is
yeah,
all that they are saying.
yeah,
Similarly, when you look at similarly when you look at the cos curve, after every 360 degree, a cos curve will repeat itself. Is it making sense?
yeah, yeah.
Okay. So period of 360, that after every 360 degree it will repeat itself. So for example, when we say a year, what we say is that every 12 months the season repeat themselves. So we
Yeah.
know that, for example, all of us who stay in Bombay, we know that every July, that is after every 12 months, it is going to rain very heavily in Bombay.
Hmm.
Anybody who has spent a year or 2 years or 3 years in Bombay understand that July would be, rain, rain, rain.
Yeah.
So that is what is called the periodicity. And of course, when you are measuring the angles in terms of radians, then the periodicity would be 2 pi. Are we okay till here?
Yeah.
Okay. Then they are saying something about the amplitude of a periodic function. Now, amplitude is something that you would have learned in class 10th when you were studying waves, if you remember. Uh,
Sound actually.
sound. In sound, they would have told you something about amplitude. And
Yeah.
here also, the definition is the same. The amplitude of a periodic function is defined as a distance between the maximum or minimum and the principal axis. So,
Hmm.
if you remember in wave chapter, in sound chapter, this is what they are
Hmm.
told you, that this is what is the
Yeah.
amplitude. So you can call this the amplitude or you can call this the amplitude. So what they are saying is that this is the maximum value and this is the
Hmm.
principal axis. So the distance is called the amplitude. Are we clear till here?
Yeah.
So now, so sine and cos, because they look almost the same, so they have grouped it in one. And now we'll talk
Hmm.
something about the tan functions. So tan function behaves very differently than sine and cosine. A tan function repeats every 180 degree. तो जो periodicity है tan function की, if you see, it repeats after every 180 degree. Is it making sense?
Yeah.
So a sine curve repeats itself after 360 degree.
360.
A
Yeah.
tan curve repeats itself after every 180 degree.
180 degree. Okay.
Is it making sense?
Yeah.
Okay. Now there's a word which is being used, asymptote. Now
Hmm.
you may or may not remember it, but just for reference sake, asymptote is something where the function gets closer, the graph will get closer and closer, but it will
Hmm.
never reach there. I'll give you a very simple example, and with that example, you will understand. So, this is the very simple example of asymptote. Now, see how it looks like. We'll only cover the positive values of x.
Okay.
Positive values of x. We are just, right now in this lecture, we are just bothered about the positive values of x. Of course, x can take negative values also, but just to make the thing
Hmm.
simpler, I'm just, focused on the positive values of x. Now,
Hmm.
if you see this, at x is equal to 1, the value of y would be 1. Is it making sense?
Yeah. Yeah. Yeah.
Now, see, interesting thing will start happening. So, for example, I put my x is equal to 10, x is equal
Hmm.
to 100, x is equal to 1000,
Okay.
x is equal to 1 lakh. Now, if you see x is equal to 1 lakh, y is equal to 1 upon This would be something like 0.00001. Am I correct? Or I think there would be one more zero. Whatever
Hmm.
number you put, whatever
Hmm.
number you put here,
Hmm.
you can put 1 lakh, you can put 1 crore, you can put 10 crore. The
Hmm.
number y will never become equal to 0, but will become more and more and more smaller. It will become very, 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 very small, but it will never become 0. Have you understood what I've said?
Kind of. Like 50% grasping it.
Okay. So, for example, I put the value of x
Hmm.
as 10 crore.
Okay.
Now, when I put the value of x as 10 crore, y has become 1 upon 10 crore.
Yeah.
What I'm trying to tell you is y will never become equal to 0, but it will become very, 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 very
Hmm.
small. Have you understood?
Okay. Okay. Yeah. Yeah.
It refuses to become 0, but it keeps getting smaller and smaller and smaller and smaller. Have you understood?
Yeah. Yeah.
So the curve would look something like this. So this is what is called that the graph is asymptotic. Asymptotic means
Okay.
that it is trying to hug an axis, but it is never able to hug that axis. So for example, now
Okay. Yeah.
if we take values less than 1, but never equal to 0. So for example, if I put the value of x,
Hmm. This is you're talking about the x value, right? Value of x you're saying is less than one.
yeah, see, this is 1, this is 1. Now I'm putting the value of x as 1
Hmm.
upon 10 crore. Have you understood what I've done?
Yeah.
I have put the value of x is equal to 1 upon 10 crore. So 1 upon 10 crore would be very close to 0, and basically it will be very close to the y-axis but will never touch y-axis. Have you understood what I've said?
Yeah.
But now if you look at the value of y, this would be 1 upon 10 crore. Have you understood what I've said?
Yeah.
And y has become 10 crore. Have you understood what I've said?
Yeah.
If you have understood what I've said, then the value would look something like this. The graph would look
Hmm.
something like this. Is it making
Yeah.
sense?
Yeah.
So on these, basically, this is what is called a asymptotic. This is what is called a asymptotic behavior. On this
Hmm.
side,
Okay.
it never is able to touch x-axis, and
Hmm.
on this side, again it is never able
Hmm.
to. Is it making sense?
Yeah. Yeah.
So have you understood the meaning of asymptote?
Yes.
Okay. So even if you haven't understood it 100%, 50%, whenever you see a word asymptote,
Hmm.
asymptote is something where the graph is trying to touch that line, but it will never be able to touch that line. And why it becomes important for us is that in tan curve, these lines, here the behavior of graph is asymptotic. So tan is trying to meet this line, but it is never able to meet this line. Have you understood what I've said?
Okay.
On
Yeah.
both sides. On both sides.
Hmm.
Now, why we need to spend some time on understanding this is because to understand this line, the tangent function does not have any amplitude. It has no maximum value, it has no minimum value because
Hmm.
you you never know what is the maximum value. It goes till infinity. Have you understood?
Hmm. Yeah.
Now, once we have understood this, now things become easier. So, y is equal to sine x. Now, y is equal to sine x would look something like this. Of course, it will go both on the left hand side and the right hand side. I'm not, drawing the left hand side and the right hand side. Have you understood what is?
Hmm.
See, it will keep going on the
Yeah.
left hand side and the right hand side. So I'm not drawing the full curve. That is what I was saying. That
Hmm.
I'm just drawing the a part of
Hmm.
a part of the sine, which is from 0 to 2 pi.
Hmm.
Am I making sense?
Hmm. Yeah.
The value of this curve is between 1 and -1. Do we agree to this?
Yeah.
Okay. Now what I'll do is I'll write it like y is equal to 5 sin x. Now this is another function. All this 5 does is, all this 5 does is, it expands the value. It basically stretches the curve of sin x like this.
Okay.
All it does is, have you understood what I said?
Yeah.
If I had written something like this, y is equal to half x, half sin x. All this would have done
Hmm.
would be, it would have limited the sin x curve like this, where this would have been
Hmm.
half. Is it making sense?
Yeah.
Okay, let us take one more example. So, sorry. So this is my cos curve. This is my y
Yeah.
is equal to cos x. Now, if I want to draw, if I want to draw a curve of y is equal to 10 cos x, all this 10 will do is it will
Hmm.
stretch the curve of cos 10 times. Have you understood what I've said?
Hmm.
Basically,
Yeah.
basically, it will make the curve of cos x like this. Is it making sense?
Hmm. Yeah.
Are we clear till here?
Yeah.
So y is equal to sin x, y is equal to cos x. So if I meet something like y is equal to 8 sin x, I know how to draw the curve. I know how to draw a
Hmm.
rough curve.
Yeah.
I don't want the exact curve, but I should be able to figure out that how the curve will look like. Are we comfortable
Hmm.
till
Yeah.
here? Okay. So this is the first thing. And now we come to the second thing, which again is a
Hmm.
pretty easy thing. So for example, y is equal to sin x and y is equal to
Hmm.
sin x plus 5. So what does this plus 5 do to this y is equal to sin x curve? Okay. So this is equal to, this is y is equal to sin x. Is it making sense?
Hmm.
Simple y is equal to
Yeah.
sin x curve. Now when I
Hmm.
add plus 5, all that it does is it raises the curve of sin x up by 5 units. Am I making sense?
Yeah.
So this point will be raised by 5 units. So this would be the first unit, second, third, 4, 5. So 2, 3, 4, 5. Basically, what this plus 5 will do is, what this plus 5 will do is, it will raise the curve of this y is equal to sine x to here.
Hmm.
This is how
Yeah,
the
understood.
new curve will look like. Is it making sense? I think you would have got an idea.
Yeah, yeah.
So if I have y is equal to cos x, and somebody asks me what is the meaning of y is equal to cos x plus 10. So all this means is that if my cos curve looks like this, all this 10 will do is,
Hmm.
all this 10 will do is, basically it will raise the cos x by, so for example, this is 1, this is 0. So let me assume I'm not much concerned about the scale. So
Hmm.
the new curve will look something like, this is how it will look like. Is it making sense?
Yeah.
So why are we discussing this? We are discussing this because what we had decided in the beginning of the lecture was that we wanted to understand what is the meaning of y is equal to sine bx plus c. So
Hmm.
y is equal to 5 sine x plus 3. What is the meaning of this? Y is equal to 5 sine x plus 3. Y is equal
Hmm.
to 5 sine x plus 3. What is the meaning of this? How does this graph look like? So just we just want an idea of how the graph looks like. So what will this
Hmm.
5 do? What will this 5 do? This 5 will stretch the curve like this.
Yeah, yeah.
And what will this 3 do? This 3 will take the curve up. So
Hmm.
from 0 principal axis, it will take it to this level. And it will be a it will be a stretched curve like this. Avantika, is it making sense?
Yeah.
So this would be the curve of y is equal to 5 sin x plus 3, and my original sin x curve would look something like this. This is my original y is equal to sin x curve. So what this 5 has done is it has given lot of amplitude to it, 5 times the amplitude.
Hmm.
What this 3 has
Yeah.
done is it has raised the sine curve up by a distance of 3.
Hmm.
Is it making sense to you?
Yeah.
See, we will, again I'm reiterating, we will require this when we are doing waves. So don't worry much about it. But I just wanted to give you an idea
Hmm.
so that, when we are doing waves, of course, we'll go into more detail. But because we had to discuss sine curves, so I thought that, we'll spend some more time and, discuss the curves in detail. Are we comfortable till now?
Yeah.
Now let us understand. See, our target was to understand y is equal to a sine bx plus c. We have understood what this a
Hmm.
does. We have understood what this
Hmm.
c does. Now we will focus on
Hmm.
what this b does. So
Okay.
when we look at y is equal to sine x, and when we look at y is equal to sine 2x. So what is the meaning of this 2? That is what we need to understand in terms of graph.
Hmm.
So this is, let us assume that this is my curve of y is equal to sine x. Is it making sense?
Yeah.
Now I'll give you a few examples. Let's hope that it starts making sense to you. Uh,
Hmm.
I put the value of x is equal to 45 degree. The value of y is 1 by root 2. I put the value of x is equal to 30 degree. The value of y is sine 30 is half. Do we agree to this?
Root half. Yeah.
Do we agree to this? Okay. Now,
Yeah. Yeah.
this is the value of y is equal to sine x. Now, for y is equal to sine 2x,
Hmm.
let us see what happens. X is equal to 45 degree, y is equal to sine of twice of 45 degree is equal to 1. When
Hmm.
x is equal to 30 degree, y is equal to sine of twice of 30 degree is equal to sine of 60 degree, which is equal to root 3 by 2. Do you agree to this?
Yeah. Yeah.
Okay. Now, what I want you to focus on and see if you are able to understand this is
Hmm.
if x is equal to 45 degree, y is 1 by root 2.
Hmm. Yeah.
But in this function, when there is a 2x, when x is 45
Hmm.
degree, when x is 45 degree, we have
Hmm.
to take a sine of 90 degree. Its value becomes 1.
Hmm.
When x is equal to 30 degree, y is half. But in this function, when we are taking twice of x when x is 30 degree
Hmm.
is 60 degree. So the value of y becomes root 3 by 2. What I'm trying to tell you guys is that for x is equal to 45 degree, y is equal to 1 by root 2. But here, due to this 2x, the 2x becomes 90 degree
Hmm.
and y takes a value of 1. So basically,
Hmm.
in this curve, y is equal to sine 2x. Basically, this is running faster than y is equal to sine x. This is what I'm trying to tell you guys. Is it making sense or not?
Yeah.
If this is my y is equal to sine x, my curve of y is equal to sine 2x will look something like will look something like will look something like this. Basically, the curve is running faster than it is completing its cycle faster than the original y is equal to sine x. Is it making sense?
Yeah.
The frequency of the wave has increased. Let me try to take some more, draw some more figures to make this easier. So for example, I had y is equal to sine. So if this is y is equal to sine x. Now, if there is a y is equal to sine 2x and there is a y is equal to sine 3x. Basically, what I'm trying to tell you is that sin x covers has a period of 360 degrees. It requires 360 degree to complete one cycle. But what I'm trying to tell you is that when you take the curve of y is equal to sine 2x, it will be able to cover its one cycle in 180 degrees only. Am I making sense or not?
Yeah.
Basically, okay. This y is equal to sine 3x will be even faster than y is equal to sine 2x in completing its cycle. Is it
Hmm.
making sense?
Yeah.
We'll see the formula, that is not an issue, but this y is equal to 3x will cover its cycle in 120 degrees. This one had covered its cycle in 180 degrees. Is it making
Hmm.
sense?
Yeah.
So, for example, if we had y is equal to sine 4x, this sine 4x will cover its cycle in 90 degree only. Is it making sense?
Yeah.
So we just want a idea of how the value of this A, the value of this B, the value of this C affect the curve y is equal to sine x. Am I making sense?
Yeah.
Now let us look at the figures. I'll share this PDF with you. Just go through the things that we have discussed, so
Yeah.
that
Okay.
so that you would have understood, say, 30 to 40% of what I am saying. When you go through this PDF, you will be able to say understand 15 to 20% more. So a level of 50 to 60% of understanding is fair enough. That is absolutely fine. When we will
Hmm.
discuss waves, then we will understand more and more about this topic. Avantika, is it making sense?
Yeah.
Okay. So we'll focus right now on y is equal to sine bx, a sine bx plus c only.
Hmm.
So so y is equal to sin x, y is equal to 2 sin x. So what does this 2 does? It stretches the sine curve. Do you see the stretch?
Yeah.
It stretches the curve.
Yeah.
Okay. Now if you
Hmm.
see, the amplitude is 2, but the period remains the same. Do you see
Yeah.
this?
Yeah.
So similarly, if we were given y is equal to 3 sin x, the stretch would be 3 thrice. It would have stretched 3 times. But the
Hmm.
period would have remained 360 degree. It would have taken 360 degree to complete the cycle. Is it making sense?
Yeah.
Okay. Because we did this y is equal to sin x plus c second.
Hmm.
So see, y is equal to sin x and y is equal to sin x plus 1. What does this plus 1 do? This plus 1 just takes the curve up by 1 unit. Is it making sense?
Yeah.
That is all that this does. Basically, from this primary axis, the axis basically shifts 1 unit up. Is it
Hmm.
making
Hmm. Yeah.
Now we come to y is equal to sine bx. Now
Hmm.
y is equal to sine bx. What does y is equal to sine bx do? There is a graph of y is equal to sine x, the standard graph.
Hmm.
This too will half the cycle.
Hmm.
What do I mean by that? So, for example, our usual curve, this is our usual curve. It takes
Yeah.
360 degree to complete.
Hmm.
But if we take the curve as a y is equal to sine 2x,
Hmm.
it basically completes the cycle in
Hmm.
180 degree only. Is it making sense?
Yeah.
So this is what we have understood. Basically, we have gone in detail for the
Hmm.
sine curve. We don't require, we don't require, we have no use for the tan, the stretch of A tan Bx plus C. We don't require much. And whatever happens in sine remains the same in cos also. So, for example, y
Yeah.
is equal to A sine Bx plus C.
Hmm.
So what does A do? It affects the amplitude.
Hmm.
What does B do? It affects the period or it affects the periodicity.
Hmm.
What does C do? It helps in the vertical translation. Is it making sense?
Yeah.
So if I have y is equal to sine x, I hope you will be able to understand what effect will these three, five would be having. Have you understood?
Yeah.
5 sin x would stretch the curve.
Hmm.
Sin 5x, the periodicity will reduce to 360 by 5, 72 degrees. Every
Hmm.
72 degrees, the sine curve will complete the cycle.
Okay.
Y is equal to sin x plus 5. The 5 just raises the axis by 5 units. Is it making
Hmm.
sense?
Yeah.
So that is all that we wanted to discuss in this lecture. I'll share this. I'll share this PDF with you.
Hmm.
Just go through the pages which I have marked that we have discussed. That is it. Nothing more, nothing less than that. Yeah.
Okay. Yeah.
And when we meet on Monday, we will be
Hmm.
discussing identities. And once we have discussed the identities, the trigonometry part would be over. Then we'll be moving
Hmm.
to vectors. Then we'll be
Okay.
moving to vectors.
Hmm.
And I think then we would be able to do few questions. Once we have done vectors, then we'll be able to do few questions from our NCRT uh, chapter. We will have few questions from vectors in the book. Yeah.
Yeah.
So what I'll do now is I'll send you the scan of identities. You will have to copy that.
Hmm.
That is the first thing. The second thing that you'll have to do is I'll be sending a lecture related to these identities. You'll have to watch that.
Hmm.
So this is your weekend homework, and we'll meet on Monday at 11. Yeah.
Yeah.
Okay. Let's meet on Monday.
Okay, sir.
Yeah.
Thank you.
Yeah.